Hello, and welcome to Algebra lesson on elimination. So today's objective is that scholars will solve systems of equations using elimination. So, first of all, let's talk about what happens if I add or subtract two equations. As you can see, I have the equation 5 plus 8 equals 13 and the equation 7 minus 1 equals 6. If I add those two equations, I'm going to add straight down, so 5 plus 7 equals 12. 8 plus negative 1 equals positive 7. And 13 plus 6 equals 19. You can see it is still a true statement. Well, what happens if instead of adding them, I subtract them? Negative 4 minus 18 is negative 22. 7 minus negative 4 turns into 7 plus 4, which is 11. And 3 minus 14 is negative 11. Again, this is still a true statement. So, now let's talk about what am I talking about when I say elimination. Elimination is adding or subtracting two equations to eliminate one of the variables. Your goal is to get it down to a one variable equation because that's the only type that we can solve. So let's look at this. If I add these two equations, I have 2x plus 3y equals 9 and negative 2x plus 7y equals 41. If I add these two, I can see this part right here is going to cancel out. So I'm left with 3y plus 7y, which is 10y. 9 plus 41 is 50. Well, if 10y equals 50, I can just divide both sides and get y equals 5. Here's the thing you have to remember with elimination. I am not done at this point. I have the value for y, but I still need to know what x is. So I need to come back to one of my two equations. I'm just going to choose the top one because it's got smaller numbers. So I have 2x plus 3 times y is 5 equals 9. So that's 2x plus 15 equals 9. I'm going to subtract 15 from both sides. I get 2x equals negative 6. Divide both sides by 2 and x equals negative 3. So my solution here would be negative 3, 5. It doesn't matter which one I find first. It's always x then y. Okay, so now let's look at what happens if instead of adding, we subtract. So here, I'm going to subtract this equation. So when I say subtract, usually we can just subtract them. If it's easier for you, you can always remember to give that negative symbol to each thing. So remember, each thing is being subtracted. So I have 4n minus 6n, which gives me negative 2n. 2m minus 2m is going to eliminate. And then 10 minus 15 gives me negative 5. So then I keep going on to solve it. Divide both sides by negative 2. I get n equals 2.5. So then I have to put that back into my equation. I have 4 times 2.5 plus 2m equals 10. 4 times 2.5 is going to be 10 plus 2m equals 10. If I subtract 10 from both sides, I get 2m equals 0. Divide both sides by 2, and I get m equals 0. Okay, so again, here my answer is, n is equal to 2.5, and m is equal to 0. I can't write it as an ordered pair because it is not x and y, but that's fine. Oftentimes, we're going to have things that are not x and y. Let's look at this. What if adding or subtracting won't work? So when I look at this system, I can see I've got a 2p and a 6p. Those wouldn't cancel. And I have a 5w and an 8w. Well, I cannot get rid of either of those by just adding or subtracting. But I have another option. I can actually take the entire equation, sorry. I can take the entire equation, one of the equations, and multiply it. So I'm going to take this top equation, and I'm going to multiply it by 3. So when I do that, 3 times 2p is 6p. 2 times 5w is 15w. And 3 times 16.1 is 48.3. Then I'm going to bring over my other equation, which was 6p minus 8w equals negative 50.6. And now I'm going to subtract the two equations. So that will go away. Remember that the negative turns this to a plus and this to a plus. So I end up with 23w equals 98.3. I divide both sides by 23. Okay, sorry, I just realized I made a quick mistake. That should be 98.9. Okay, so then I divide both sides by 23. I get w equals 4.3. And again, I just go back and put the w into one of my original equations. I'm going to take the one I changed. Do this in red. Okay, so I have 2p plus 5 times 4.3 equals 16.1. So I end up with 2p plus 21.5 equals 16.1. I subtract 21.5 from both sides. Sorry. I subtract 20, so 60.1 minus 21.5. So I end up with 2p equals negative 5.4. Divide both sides by 2, and I get p equals negative 2.7. Okay, so this works even when we have decimals. So let's talk about how do we decide which equation we want to multiply. So we're looking for a coefficient that is a factor of the other one. So here, I can see that I can eliminate x if I got this 2 to become a 4. So I can multiply this whole thing by 2 and then solve it. Over here, I can eliminate this by multiplying that by 3. And again, the big thing, remember, you can eliminate either of your variables. Don't feel like you always have to eliminate the first one, the second one. You can eliminate either one of your variables. So let's look at what happens when we do this. So this equation on the bottom is going to turn into 4x minus 6y equals negative 20, which you'll notice is the exact same equation above it. So when I actually subtract these, I'm going to end up with 0 equals 0. Well, just like when we solve regular equations, that means that this is a true statement. So it has infinitely many possible solutions. Okay, so let's look at this next one. When I multiply by 3, this equation becomes, oops, change color, sorry. That equation becomes 3x minus 15y equals 36. And I bring over the other equation, which was 3x minus 15y equals 24. When I subtract these, I'm going to end up with 0 equals 12, which is not true. So this one has no solution. Okay, just like it was when we did our one variable equations. Okay, now let's talk about what if it is a word problem. I know you guys get to word problems and like to freeze. So let's look at this. A ferry is making a round trip from point A to point B. Going downriver, the boat is able to travel at 12 kilometers per hour. Going back upstream, the boat is only able to travel at 6 kilometers per hour. What is the boat's speed in still water, and how fast is the river flowing? So let's try to sort of imagine this. So I've got a river, and it's moving. My boat is trying to go down this river. My lovely boat. If it's moving with the tide, it would have it added to it. If it's moving against the tide, it would be subtracting from it. So it's sort of like the tailwind and headwind with airplanes. So, I'm going to call the boat's speed B and the river R. So, when the boat is traveling with the river, it's able to travel at 12 kilometers per hour. When the boat is traveling against the river, it's only able to travel at 6 kilometers per hour. I'm going to add these, and I end up with 2B. Remember, this part's going to eliminate, equals 18. Divide both sides by 2. That means B equals 9. So my boat is traveling at 9 kilometers per hour. I can put that 9 into either of the equations and get that my river is traveling at 3 miles per hour. Or kilometers per hour, sorry. kph. Make sure that you write your final answer in the form of a sentence because this is a word problem. Okay, so go ahead and do your practice problems, and I will see you in class.